This is a tutorial for step 6 of FORCsensei processing, and we're now ready to compare all our different VariFORC models. If you remember, in step 5 we set up the model comparison in terms of the parameter space for the different VariFORC models to be compared, and downsampling number of processors we're going to use, and we're going to compare 220 different VariFORC models. So to start to compare these models is simple. We just check compare models and the calculation will start. You can see we've got little cogs here telling us that the processing is underway, and there's a lot of computation to be done. We're comparing a large number of models. Now, if you're working on the cloud, unfortunately you can't track the progress of the calculation. The information on the cloud of how much CPU is being used, how much memory is being used, etc., isn't made available to the end user. However, if you're working with a local installation, you can get the information about the progress of the number of models and how far through the comparison goes. So if you go to the FORCsensei website and you look on the FAQs page, what you'll find is a link here under the question, is there a progress bar to monitor the model comparison process? And if you click on that link, it will open a new window in your web browser which will show you all kinds of things in terms of the number of workers, what CPU usage, what memory usage they have, and so on, the tasks that are ongoing, an overall status screen, and so on. And this will give you then some idea of the progress of the process. Now, this can actually take a little bit of time. On my laptop, I would expect this to take about 10 minutes. If you're working on the cloud, because they offer limited computational resources, it can be very slow on the cloud. And because a free cloud service, what they don't want is people setting huge jobs going and then walking away from their computer. They will actually disconnect you from your job after about 5 minutes. So it's important, if you're running this on the cloud, that you keep your session active, for example, just by moving the screen up and down a little bit every now and again. But if you do get disconnected from your session on the cloud, it won't tell you. You'll simply just see the cogs going around forever. Okay. Now, I'm working locally, so it's gone very quickly, and in fact much more quickly than I expected. So we've now got the result which is being displayed underneath the compare models button. So we've got the model comparison result. It tells us what the optimal VariFORC smoothing parameters were. So the minimum on the horizontal was a smoothing factor of 3, with a maximum or SC1 on the horizontal of 5. On the vertical it's 3 and 5, and a lambda of 0.04. Now, we've got a distribution of model performance here, where each of the points in the ternary plot represents one of the VariFORC models that we calculated, and its tendency to either underfit, overfit, or give an optimal model on the basis of our size statistic, which is explained in our paper. So I'd refer you to that for more information. But what VariFORC does is select the optimal model on the basis of the number of local regression cases that correspond to a second order polynomial surface. So this is the one highlighted in red here. So that's our optimal model that has been selected. The other models, each one represented by a point, are color coded according to their psi value, but basically the closer that they get to this optimal end member here, they'll go towards blue through to yellow coloring. So we've selected our optimal model. The optimal VariFORC model can also be shown in terms of moving across the fork space. For that optimal model, where do we see cases of overfitting, where do we see optimal fitting, and where do we see underfitting? Now, in this case, you can see the blue regions. They're the points in the fork space that do correspond to a second order polynomial surface. Cases where we have black and orange, they're cases where we appear not to have second order polynomial surfaces. Although it's difficult to tell here, these are mostly away from the main body of the fork diagram. So we've got a psi value of 0.38. That means 38% of the cases in the local regression were consistent with a second order polynomial surface, and as we saw in our ternary plot, that's actually the maximum for the combination of variforks that we considered. So this is deemed to be our optimal model. Now if I go through to my Finder window, you'll see we've output a number of new PDFs. So we've got the PDF corresponding to the ternary plot that we just looked at, and that's editable. We've got a PDF corresponding to this plot here that shows you the different orders, and we've also got a text file that is a simple report telling you what these different varifork smoothing parameters were for the optimal model. So those are saved on to your system in the same location as the FORCsensei notebook. As we discussed in an earlier cloud tutorial, if you're working on the cloud, these will be saved into the cloud workspace, and you should download them and save them somewhere on your local system. So now that we've estimated the optimal model, we can go on to our next step, step 7, which will calculate our final fork model.